Welcome to the introduction on IoT. In this lecture, we will get introduced to the fundamental concepts behind IoT along with an overall understanding of IoT. Let's first get motivated about why IoT is required. It is anticipated that all the things that are around us are all going to be interconnected. As of now, all the services that we enjoy is a network of computing devices. IoT says that the scope will be expanded to physical objects and very simple objects such as lights, ACs, toothbrushes, refrigerators, and so on and so forth. This is beneficial to our lifestyles and businesses as the machineries could be interconnected and easily monitored. To get a better understanding, let us move on to the pros and cons of IoT. Now, the advantages include improvement in health and lifestyle by IoT-enabled monitoring devices, saving costs and energy by allowing appliances to communicate in an effective manner. The information gathered can be used to make better decisions. Also, better machine-to-machine communication or M2M communication. Hence, transparency is available with greater quality and lesser inefficiencies. It also increases productivity and profitability of businesses. On the downside, it is observed that IoT is making humans overly dependent on technologies by increasing these dependencies on our daily routine. As there is the involvement of different technologies and devices, there is monitoring by more than one company, which directly questions the security and privacy issues. Also, due to the automation, there will be fewer requirements of human resources and less educated staff, which may create unemployment issues in the society. Also, there are no international standards to implement IoT. Lastly, with all complex systems, there is the possibility of failure. Failures could be skyrocketed in the case of Internet of Things. Now, what is IoT? IoT is an internetwork of physical things with embedded electronics in their architecture that allows the devices to communicate and interact amongst each other with respect to the external environment. This internetworking technology is connected typically by wireless technology such as Wi-Fi, Bluetooth, Zigbee, and other such technologies. IoT is supported by technologies such as cloud technology, big data, machine learning, embedded systems, and networking. Some of the enablers are RFID technology, sensors, and smart networks. In order to be able to implement IoT, we have to accommodate all these things that act as a node in the network. There are two ways to connect these objects. By expanding the scope of the existing internet, that is, all the things would be connected to the internet, and the other approach is to develop a separate internetwork from scratch. Both these methodologies have their own challenges. Moving on to the characteristics. Some of the characteristics of IoT involve the network to be efficient and also scalable, so that even if the network includes billions of nodes, the overall network performance should not be compromised. We would also require a new way to name and address the devices. Also, inactive devices must go into a sleep cycle. Intermittent connectivity is also an interesting characteristic. A mobile device from a network connected to a device may not be connected at a later instance. In terms of application domains, IoT is attractive in various application domain spheres. For instance, manufacturing, which has the most market share, healthcare, security, and retail. So when we talk about business and manufacturing, we speak about the improvement of the entire supply chain. Second is the healthcare, which covers monitoring, record keeping, and remote treatments. The third is retail sector. Tasks such as inventory tracking, anonymous analytics, and consumer choices are covered. And the last is security, wherein facial and biometric recognition-based security systems are enabled by IoT. Coming to the evolution of IoT, which started right from the creation of World Wide Webs and the internetwork of ATMs. IoT is one of the building blocks for developing smart homes and smart cities to the present day, wherein we have smart vehicles, homes, cities, wearables, and even smart dust, wherein smart dust are smaller computers which are even smaller than sand itself. They can be sprayed to measure chemicals in soil and to diagnose problems in human body. Moving on to the connectivity layers. In terms of connectivity layers, there are three connectivity layers: the service layer, local, and global connectivity layers. The global connectivity layer has the internet. For local connectivity, we have gateways. And for service level, there are different services that are given to banks, factories, health sector, agricultural sector, etc. A number of technologies that are closely related to IoT are machine-to-machine communication, Web of Things, and also cyber physical systems or CPS. Moving on to machine-to-machine communication, IoT and M2M or machine-to-machine communication go hand to hand. But M2M is concerned only about interactions amongst machines, whereas IoT is inclusive of M2M. IoT has a broader scope since it comprises a broad range of interactions which includes machines, things, people, and applications. Moving on to WOT or Web of Things. IoT and Web of Things are often confused. Web of Things concentrates on web technology such as HTML5, JavaScript, Ajax, PHP, Ruby on Rails, etc. So, this would bring us to the end of the introduction to Internet of Things. We have learned that IoT is a network of physical things with embedded systems. It is believed that it is the next frontier in technology and will impact all aspects of our lives. Thank you.